Okay, so the next step now is to write the actual test cases for our test suite. So we got our test suite here, which is a test suite for this particular function block. What I usually do is that I create a private method for every test case that we want to run. And the naming of this test case can be anything. I've seen people just call it test 1, test 2, and so forth. However, that is not very descriptive, and if you're gonna look at this code in many years from now, or if someone else is gonna look at this code, it's just nice to give this test case a little better name. So for instance, now we can write a test that just adds a couple of numbers, and we should expect a certain average out of that 5 numbers. So I'm just gonna create a very basic test here. Let's call this add 5 numbers, expect average of all, and it doesn't return anything, and it's private. Okay, so this immediately gives the reader of this test case a little better understanding of what this test case actually does. Now we need to declare some variables. First of all, we want to create an instance of the function block that this test case is actually going to be for. So in this case, it's the moving average function block. And let's just do like this. And as you remember, there are 2 parameters that are necessary when we instantiate this function block. One was storage array. And for that, we need to provide an address of something here, of an array that we need to provide, and a filter size. So the filter size can be, for instance, so we're gonna have 5 numbers. We can just put it to 5. So we need to have some storage array. So let's just create that data array. So this is just the storage that is necessary for us to put all the numbers in that we're gonna do the filtering on, the moving average on. So just, okay. So this is the address of that data array that we just created. All right. A test case is declared by doing like this, just test, and then giving it a name. And in this case, what I usually do is that I always use the name of the method. So I just call it this, which is kind of nice, because if this, for instance, what this is used for is if the test fails, then this information is provided in the human readable text output later on. So now we can just define the test, which is calling the moving average function block, adding a data point of value, let's just make it simple, 1.0, and do it 5 times, okay? 5 times. And here's the thing. Now we're gonna call the assert method, which is used to verify that the output is what we expect it to be. And as you remember, we instantiated it with the name assert. So let's use that. Assert. And then you can see that here we got an assert method for every data type available in TwinCAT, including arrays. So what we would want to use here is long real. But what I want to show you here is that you have an assert equals that takes any, which is a very nice addition that Beckhoff added quite recently to TwinCAT. So here we can provide any data type. So the expected value is 1.0, okay, because the moving average of 5 1.0 is 1.0. And the actual value, that's the value that we get from the actual moving average function block that we haven't implemented yet. But we have created the interface for this. So we have the getAverage method that we've created previously. So that is the actual value, and this is the value that the method will actually calculate, the function block will calculate. And then you can provide just a message which is only shown if this assert fails. Okay, so we can just write moving average value not correct, right? And yeah, that should be it, more or less. And now we just need to make sure that this method, this test, is called in the run test, which is called from the TcUnit test framework. So just call it, yeah, and compile. Okay, so we got some compile errors here. Yeah, okay, so the thing with this assert equals that takes any, it requires that the any input, so if you just look at this one, you see, it's, let's see, you see any type. This is a built-in thing in TwinCAT3. This any type is, it has to be, the input needs to be with write access, which obviously this is not write access. So we just need to provide some temporary variable. I mean, if we were gonna use the assert equals long real here instead, we could do it just like this. But with the any type, we need to provide this as a writable input. So we can just create a temporary variable called expected value. That is a long real, that is 1.0, and then a current average is a long real. Then the expected is the expected value. Then the current average is this. And now it should be happy because both of these are writable variables. Though obviously this will never change during the method call. So let's compile it again. Yeah, and that's, let's see, where is the output here? Yeah, anyway, it compiled. So that is fine. Now we can just, and that's the first test. So it's that easy. So let's just create another test. Another thing I think we should test is what if the user has a filter of size n, I mean size 3 for example, or whatever, and but only adds one number. Only what adds one number. We must make sure that the moving average is calculated correctly in that case as well. So let's create another one and call it add just one number, expect average to be that one number. Not a fantastic name maybe, but I think it clearly describes what the test is supposed to do. And private. So again, the same thing. We need to have a data array with the values, array 0 to 4 this time, maybe, long real. And the moving average, the instance of the moving average function block. Storage array is address of data array. And filter size can be, it can be 5 this time as well. It doesn't matter, or 3 or whatever. And let's create a test and give it the same name as the method. Again, it doesn't have to use the same name. It's just that it it doesn't make sense to call it anything else here. And then we just add a data point. So moving average, add data point, and some number. It's 113.0. Okay. And if we're gonna assert that. Let's use the same thing, the any version. That the expected value is 113. But again, we need to use a writable variable here, so let's just create an unexpected value variable, long real. So expected is expected value, actual is here again we need to create a temporary writable variable, current average long real is average, and message just whatever, just moving average value not correct. Okay, so here we're checking that if we're only adding one data point, even though the filter size is 5, I mean the moving average of just one value is the value itself. Okay, so let's compile this. Yeah, before we compile it, make sure that we call it in run tests. Now we can compile. Let's see, view output. There we go. And I put it here. Let's compile it. All fine. Okay, so I think I want some more tests. Again, I just like to come up with all the tests I can think of. This is the nice thing with doing test-driven development. The nice thing with unit tests, I don't have to wait for running this on any machine or in the actual hardware. I can just do whatever tests my fantasy can come up with. So another test might be to maybe add less numbers than the filter size allows. And just check that we still get the average. So if you have a filter of 10 and add just 4 numbers, the moving average should be those 4 numbers. So another, let's call it add less than filter size, expect average of added values. So again, let's create an instance of moving average function block, which is the unit under test. Storage array, yeah, we need to create a storage array. Data array 1 to 5, long real is the address of this guy here, and the filter size again can be 5. And let's create a test. And not this time we're not gonna add 5 numbers, but we're not just gonna add 1 either. We can add 2 and see that the moving average is 2. These 2 numbers combined, added together and divided by 2. So moving average dot add data point, for example 110, and another one 5, and now we can assert. This time we can actually do an assert equals not with the any type, but using the one for the actual data type, long real. As you can see, you don't only have expected and actual here, you also have delta, and the delta is only for long real and real, and the reason is because this is how floats are working and are stored in the computer. So we need to provide what the maximum delta is between these 2 values, but still consider both numbers to be equal. So expected here is now we can let's take the calculator. So 110 plus 5 divided by 2, 57.5. Okay. So now we don't need to create any temporary variable. Now we can use these directly. And actual is the calculated value that the moving average should give us. So get average, which of course isn't yet implemented, but which we will implement after we have all our tests. The delta can be, let's just put it to some low number. I mean, it should be more or less. In this case, it will be exact because there's no rounding or anything in this case. And the message is moving average value correct. Yeah. So that's another test. We should compile it. Yeah, actually we need to add it to the run. And now let's compile again. Fine. Another test. Just love to write tests. This time we can have a test where we add more values, not less, but more values than the filter size. So add more than filter size, expect average of last added. So yeah, the last one added of that is the filter size. And again, private bloop, and let's see, test. I mean, when you've done this for some time, all of this gets quite, you get into the flow. Data array, let's use some fantasy, and let's start addressing from 4 to 6, which of course the function block should be able to take care of. I mean, this is the funny thing with IEC. I mean, with structured text, this indexing. I don't know any other language where the array doesn't start at 0, but can start at an arbitrary number. But I actually like it. Anyway, of log real, and then we instantiate the moving average function block. Storage array filter size, so 3. Okay, so quite small filter. And now let's add more numbers than 3 to this. So moving average add data point. So let's do it like this. So then let's add 4 numbers. Okay, the first one can be 4.5135. The second one can be 84.76436. Next one can be 257.123. Next one can be 5.3414. And then we can call the assert e. Okay, let's use this guy again. Expected should be, the expected one should be because the filter size is 3 and it's a moving average filter, it should be, this one should not be taken into account, it should be this 3. Okay, so again, let's use our wonderful calculator. This is a really big calculator. Okay, so 4.51, no, sorry. Yeah, we were just gonna take these 3. 84.76436. Yeah, plus 257.123 plus 5.3414, right? And divided by 3. Let's see if I can copy. Okay, so the expected value is that, and then the actual will be what the function block provides, which is moving average dot get average. And the delta can be, I mean, again, we can put it quite large. It didn't round here, so it should more or less be, it should be exact. And a message of moving average Yeah, so we have 4 tests now, and let's just make sure this test is called and compile. Okay, I think 4 tests are quite good, but let me think. I mean, we could also create a test where we have a bigger storage than the filter. I mean, where the data array where we store our numbers is much bigger than the filter. I mean, that shouldn't matter, right? But it's nice to have a test to see that our moving average function block takes care of that, and that the user basically can do whatever he wants to do. I mean, he can provide a bigger filter, a bigger data array for the storage. That's fine. So let's add another test here. Let's call this use bigger storage than filter size, expect average of filter size. Someone is gonna kill me for these long names, but it's good that we have this nice widescreen monitors these days. Okay, so test like this, and again data array. Now let's create an array of 5 data points, but the filter can be smaller, so the filter can be 3. Moving average is an instance of moving average, where the storage array is equal to address of data array. Filter size is 3. Okay, so the filter is a little bit smaller than the size of the data array, and again, I mean, this should be fine because we have enough space to store the data points in, but we only care about the three last inputs. Okay, and this time we can use the any version. So let's prepare the expected value. Sorry, not real. This is gonna be something, and current average. And now let's add some numbers. I don't know, something like this. Just start with 2, 3. Yeah, my fantasy here is quite lacking, I would say. I mean, it's obvious that this is not very random, but my brain is really bad at making up random numbers, which doesn't matter too much for this test. And the current average will be moving average get average, right? So the expected value will be the moving average of the filter size 3, so the last 3 numbers, so these, and these actually have a, the center point here is 11. I mean, if you take this one plus this one plus this one, divide by 3, you will get this number, okay? Because it's equally spaced between these. So the expected value is 11.0. And assert equals expected is expected value. Actual is current average, and message again moving average value not correct. Yeah, so we're adding a bunch of numbers. I mean, we can just continue because we could add hundreds and thousands of numbers, but we still only care about the 3 last ones. I mean, yeah. Okay, so let's see, and we need to call this method. So that's our 5 tests. I think for now this is actually quite fine. Okay, so we're almost ready to run the tests, The final thing we need to do is to tell the unit testing framework that we have that the tests are finished, so that they have been finished running. The reason we need to do this is because the user has the possibility and the option to have a test suite that spans over several PLC cycles. In this particular case, our tests, they only need one PLC cycle to finish. I mean, if you just look at one of these guys, it adds some data points, calculates the moving average, and then we do an assert. All of this can be done in one single PLC cycle. And this is accomplished by setting the return value of this method to finished. So normally, if you would create a test suite that spans over several PLC cycles, you would want to have some sort of state machine here internally so that the function block under tests has the possibility to finish. Okay, and now we can see that we're finished. Everything is done. We instantiate the test suite. The test suite in turn is declaring these 5 tests and running them in run tests. And then we're also calling the TcUnit framework here to run all of these tests in all of these test suites. In this particular case, we only have one test suite. So let's compile it. Let's see if it compiles. Looks good. And okay, so the icons are gone here for some reason. Base. And let's put it in the runtime system. Okay. And let's run the tests. Okay, so you can see we got a lot of messages here, which is the case when we have failed asserts. So all of this are outputs from the failed asserts. That is when we call the assert equals long real or whatever. And we also have a summary of all the tests from the test suites. So we only have one test suite here, which is this moving average test, because we only have one function block. And again, I mean, we can define as many test suites as we want, but in this case, one is just good. It's good enough. And we have 5 tests again. 1, 2, 3, 4, and 5. We don't have any successful tests because it's kind of obvious. We haven't done the implementing code yet. So obviously all the tests will fail. And we have 5 failed tests. And if we look at these messages here, it's quite interesting because here we can actually see the complete search path to the test. So we can see the program itself, the instance of the test suite, because we called it, so we go to program tests, here. So this is the instance of the test suite, and you can see the name here, and the name of the tests. So as you remember, we declared add 5 numbers, expect average of all. This is the name of a test, and it's this one. And the value that is expected, so the value in this case, the expected value, we said that the moving average of a bunch of 1.0 will be 1.0, but we got 0.0 back, which is of course obvious because we haven't done the implementing code yet. And just the message, moving average value not correct, which is what we provided here. So this is kind of neat, I would say, to have this, to have all of this information, so we can immediately start to dig and see why doesn't this work. So it's quite nice. With all of this, with all our tests, I mean, now all our tests are running, we can start to do the funny thing, which is doing the actual implementation code.